Dear students, welcome to Nivi's Patashala. In this video, we will be studying about non-deterministic finite automata. In this example, we will construct NFA to accept strings ending with A, B, A. So, the minimum string is A, B, A and the input alphabets are A and B. Now, while constructing the NFA, I have string ending with A, B, A. So, I will require n plus 1 states. So, I need 4 states to construct the NFA. I have Q0, Q1, Q2 and Q3, where Q3 is the final state and the minimum string A, B, A is accepted by the NFA. So ending with A, B, A means the string can start with n number of A's or B's, where the string has to end with A, B, A. Only then it should be in the final state. So my string can start with n number of A's or B's. So this is the completed construction of the NFA. Now if you are wondering what will happen if I have a string A, B and if I have another B. In DFA, we will give all the rejecting strings also will be having another path to go. But in NFA, A, B and if I get one more B, the string will get terminated. In DFA, we will make sure that the string is in a non-final state. But here in NFA, we need not worry about the rejecting strings. The string will automatically get terminated if it is not ending with A, B, A. So this is the completed NFA. Now in the step 4 we have transition table and mathematical representation. So we can see that Q0 on input A can either loop Q0 to itself or it can go to Q1. Here we can see Q0 on A can loop it to itself or it can go to Q1. Then Q0 on B is looping to Q0 itself. And Q1 on A has no transitions. Q1 on B can go to Q2. And Q2 on A can go to Q3 and on B it has no transitions. Q3 has no transitions on input A or B. In the mathematical representation, we have Q for all the states, that is Q0, Q1, Q2 and Q3. The alphabets are A and B. The start state is Q0 and the final state is Q3. So let us take another example. To construct NFA accepting strings of the language, we have A, B power n or A, B, A power n where n is greater than equal to 0. Here it is not whole power n. So it means A, B, A and this power n is only for B power n. Here also it is A, B and we have A power n. So let us see the accepting strings. For AB power n, when n is greater than equal to 0. So the minimum string when n is 0 we have is AB, A. When n is 1 we have AB, AB. When n is 2 we have AB, ABB. Here only B's can be increased. We can either have B or we cannot have B at all, or we can have n number of B's. So minimum string is ABA. This ABA has to repeat. This B can repeat or cannot repeat. It can also repeat n number of times. And for ABA power n, the minimum string is AB when n is equal to 0. When n is 1, we have ABA. And then n is 2, we have ABAA. N is 3, ABAA and so on. So here the minimum string is AB. This A can either repeat or cannot repeat, or it can also repeat n number of times. So the minimum strings are ABA or AB. So we can see minimum string ABA or AB when n is equal to 0. So the input alphabets, the input symbols are A and B. So let us construct the NFA. First we'll construct for AB power n. So I have AB power n. Minimum string is ABA. So we can see on Q0, A is going to Q1, on B it's going to Q2, again on A it's going to Q3. So the minimum string ABA is accepted. After that, n number of B's can repeat, and that is also in the final state. Q3 is the final state. Now I will construct for AB, the minimum string AB. So here I have taken another two states. From start state Q0 I am giving A to Q4 and B I am giving to Q5. After that we can either have A or we can not have A. That doesn't matter. So A, B is in final state. Q5 is the final state here. N number of A's can be repeated and still it will be in the final state. Here we need not worry about what will happen if my string starts with B. This is construction of NFA. If my string is starting with B, I need not loop B here because the string will automatically get terminated if it doesn't start with A. So it has to start with A, it has to have a B, it has to have an A to reach Q3, minimum string. It has to have an A, it has to have a B to reach Q5. So if we are wondering what will happen if we have n number of A's here or B's here, the string will get terminated. We need not do any further constructions. So here we have the transition table and the mathematical representation. This is the completed NFA diagram. We can see that Q0 on input A can either go to Q1 or Q4. So we have written Q0 on input A can either go to Q1 or Q4. On input B there is no transitions on input B. Q1 on input B is going to Q2. Here Q1 on input B is going to Q2. Q2 on input A is going to Q3. Q3 on input B is looping to itself n number of times. So Q3 on input B is going to Q3 itself. Again Q4 on input B is going to Q5. Q5 on input A can loop to itself. So Q5 on input A can loop to itself. This is the start state. Don't forget to mark the start state, and these two are the final states, Q3 and Q5. And this is the mathematical representation. Q represents all the states, Q0, Q1, Q2, Q3, Q4 and Q5. The input alphabets are A, B. Q0 is the start state, Q3 and Q5 is the final state. So for the same example, let us check if AB, ABB and ABA, BA is accepted or rejected by the NFA. So first let us see ABA, BB. So the first input cell is A. So from Q0, A can either go to Q1 or A can either go to Q4. So from Q0, A can go to Q1 or A can go to Q4. Now my second input cell is B. So from Q1, B can go to Q2. From Q4, B can go to Q5. So from Q1, B can go to Q2. From Q4, B can go to Q5. Now my third input cell is A. So from Q2, A can go to Q3. From Q5, A can go to Q5 itself. So here from Q2, A can go to Q3. From Q5, A can go to Q5. Next input is B. So the fourth input is B. So we are in Q3 here. From Q3, B can loop to itself. From Q5, there is no B that is going outwards. So I have marked Q5 red here, which means there are no moves here. So this gets terminated here. Next, the last B, I am in Q3. So the last B again gets looped to itself. That is Q3 on B is again in Q3. Now Q3 is a final state, therefore it is accepted. So AB, ABB is accepted. How does it move? From Q0, A goes to Q1. From Q1, B goes to Q2. From Q2, A goes to Q3. From Q3, B again goes to Q3 itself. Again from Q3, B is getting looped in Q3 itself, and because Q3 is a final state, this is a accepting string. Now let us see for ABA, BA. So starting with start state, we have first input cell having A. So Q0 on A can go to Q1, Q0 on A can go to Q4. So here Q0 on A is going to Q1, Q0 on A is going to Q4. Second input cell is B. So Q1 on B is going to Q2 and Q4 on B is going to Q5. So we have Q1 on B is going to Q2, Q4 on B is going to Q5. Third input cell we have again is A. Q2 on A is going to Q3 and Q5 on A is repeating to Q5 itself. So Q2 on A is going to Q3, Q5 on A is going to Q5 itself. Next fourth input cell we have is B. So from Q3 B is getting looped to Q3 itself. From Q5 we don't have any other output for B. So therefore Q5 stops here. There are no moves. Now the last input we have is A. Here from Q3 we have no output going for A. So from Q3 A cannot go anywhere. It is having only looping B's. So Q3 also gets terminated. The string gets terminated here. So AB, ABA doesn't get accepted. So we have AB, ABB is accepted. AB, ABA is rejected by the NFA. Thank you for watching. Don't forget to like, share and subscribe.